Let us prove this theorem. Let f be a function from a to b. Then f composed with identity on a equal to identity on b compose f. So f compose identity in a. What is that? So we know a to b, f is a function from a to b. We know identity is a function on a is a function from a to a. Send any point x in a to exact point x, right? And x sent to f of x in b. Okay, so we have this. The function f compose identities a is the function from a to b that send x to f of x. Okay, so this we know first. The left hand side is a function from a to b that send x to f of x. What about the second, the right hand side function? This identity on b compose f. So we know that f is a function from a to b. Now we have identity function on b. Send any point b to b, to exact that point b. So we have the identities compose identity on b compose f is this function. Identities on b compose f is function from a to b. What does that send to? Any point x on a map to f of x in b. F of x in b map to f of x itself in b through the identity map. Okay. So this function send a point x in a to identity in b of f of x by definition, and this is okay. So we know that this function identity compose f send x to f of x is the same as f compose identity, which is this right hand side function. Now we prove it. Remember, we need to prove two functions are equal, right? There was a theorem telling us the two functions are equal if and only if the values of any point x is the same. Let me show you the function here. Let f be a function from a to b. G is a function from a to b. F and g are equal if and only if for all x in a, f of x equals g of x. We will use this theorem. We will show that for all x in a, f compose identities a of x equal to identities b compose f of x. Okay. We have just go from the left to the right. F compose identities of x equal to, by definition, f of identity a of x. This is f of x because identity a send this point x to itself. Okay, we want to have this. This is, recall that f of x is an element in b. F of x is an element in b. X into f of x. So this we can say is equal to identities b of f of x. And by definition, composition. This is the compose of identities on B f of x, and this is the right hand side. And we did prove it. So these two are the same for all x in A. And therefore the two functions must be equal. These two are equal, and we're done with the proof. And in the proof you don't have to write this part. I just show you what is the domain and the codomain of the function base. They are equal, the same. Domain of this function is A, also domain of the other one also A. Domain this one is B, domain of the other one is B. The value we see exactly the same, f of x. So the two functions equal.